Radio waves are part of the electromagnetic spectrum, which also includes X-rays and visible light. Generation of radio waves uses the relationship between electricity and magnetism. If an electric battery and a magnetic compass are joined in a circuit, whenever you complete the circuit, the compass needle moves. The magnetic field that has been created can also be detected in another circuit placed near to the first. This is how radio waves travel across space. With powerful transmitters, they are sent very long distances and picked up by an aerial on the receiver. To send complex signals, a sine wave can be used, which is continuously changed through modulation. The height or amplitude of the wave can be varied, or its frequency. The number of wave crests per second, which is counted in hertz. The varying pattern carries the message. The wavelength is the distance between wave crests and is typically hundreds of meters for radio waves. But the frequency is millions of waves per second because radio travels at the speed of light. There are very many radio waves all around us, so a receiver must have a tuner in order to isolate a particular signal, as well as an amplifier to make it stronger. Modern digital radio breaks the signal into pieces coded as numbers, which are reassembled into sound at the receiver. They are transmitted across much wider frequency bands than analog radio. This gives a more reliable signal, and it means that one digital signal can carry many programs at the same time. Radio frequency bands are allocated for different purposes. Television, for example, uses higher frequencies than radio broadcasting. ITU is where international agreements are made about allocating frequencies for the many services that use radio today, including mobile phones and other devices.
The speed and flight pattern of a remote-controlled model airplane are determined by the joystick positions of a radio controller. Based on the position of the joystick, the controller emits radio wave activity at regular time intervals lasting for a specific length of time. These radio wave pulses are transmitted to a receiver in the plane and converted from analog to digital pulses. These digital pulses are delivered to a servo motor, instructing it to hold a particular throttle or flap position. The width or duration of the pulses will vary based on the position of the joystick. The control pulses only last a few milliseconds and repeat about 50 times per second. A specific series of impulse signals will hold the servo horn in a fixed position. Let's look at the operation of a servo motor in more detail. The horn of a servo motor can be activated to hold certain positions. This position is set by the length of a radio pulse arriving from the radio controller. The servo expects to receive a converted digital pulse roughly every 20 milliseconds. This train of pulses instructs the servo motor to hold its position. It is the pulse duration repeating at regular intervals that tells the servo where to turn. For example, if the pulse is high for 1 millisecond, then the servo horn position can be programmed to be at 0 degrees. If it is 1.5 milliseconds, it is set to the center or 90-degree position. If the pulse signal is 2 milliseconds, then it can be instructed to go to the 180-degree position. The servo motor can be programmed to hold positions at any range of angles necessary to provide the precise control required to adjust the flaps. Varying the pulse width is all that is required to determine the position the servo motor will maintain.